Good morning and welcome to the Midwest Technical Inspections virtual seminars. My name is Doug Bennett. I'm one of the Quality Assurance and Training Managers here at MTI. This morning's session, we'll be continuing with part 2 of the CL 101. So we're going to be covering the multi-peril survey, but we are right in the middle now. So we're going to start with the premises liability, and then we're going to move on to the operational exposures to end out the session. So we'll go ahead and get started here. And for premises liability, the first part of that is just going to be looking at the generic slip, trip, fall, bump. So the good thing about this is pretty obvious. Usually, this is just common sense type of things. Anywhere that you see somebody could slip or trip or fall, that's what we're looking for here. So things like bad stairs or like elevated walking surfaces, or anything like that where somebody could catch their toe and trip and fall. Here we're looking at obviously the crumbled stairs are horrible here, where somebody could easily slip and fall on those. But also we are looking at the handrails on this one too, because for all stairs with 3 or more risers, we're looking for a handrail. So now the handrail depends on how wide the stairs are as to how many handrails they need to actually have. Now with this particular handrail, we do see that they have the handrail down here at the far end of the stairs, but based on the condition of the stairs, one of the first things I would do is I would go over and give that handrail a good shake, see if it doesn't just come off in my hand there. I want to make sure that it's something that's going to be able to hold up a person. If they start to stumble or fall, they can grab it and hold themselves up with it. So assuming that it's in good condition, that it's solid and able to hold them, the next thing that I note is that it is all the way down at the far end. What happens if somebody tries to walk up the stairs over here? They're not going to be able to reach that handrail if they start to stumble and fall. So for handrails, they say that if the stairs are less than 5 feet wide, then you just need to have a handrail on one side or the other. Now, as soon as you get more than 5 feet in width, then you need to have a handrail on either side, and you should never have a span of more than 5 feet without a handrail. So if you're like a 15-foot wide stairs here, then you'd have to have one on either side and one in the middle, so that you never have more than a 5-foot span without a handrail. So that's just something to take a quick look at when you see these stairs. And again, it's 3 or more risers. So if we're looking at this one, we see here's the first riser, here's the second riser, here's the third riser. So that's 3 steps up. So it would require us to have a handrail. Now, most building codes will say 30 inches. So this would probably, looking at this one, is probably going to be less than 30 inches. But the best practice, or the industry standard, would be 3 risers. So even though it's not quite the full 30 inches, they should still have the handrail on that. And this is a common recommendation that we do make, is to get the handrail on the stairs, especially on like rental dwellings, or where it's a private, where it's a home that somebody's renting out, or it might be like a bed and breakfast or a Verbo or something like that. A lot of times those exterior stairs there don't have the handrail that they're requiring. Other items for the handrails to keep in mind is that the handrail is supposed to be graspable. So sometimes you'll see things like a 2x4 being used as the handrail, and the average person is not going to be able to really grab a hold of that 2x4. It's supposed to be round and about 1.5 inches in diameter. That's the ideal, is a rounded 1.5 inch diameter pole type of handrail, because that's going to be something that the average person can easily grasp and hold on to. We also are looking at the fall protection, as far as so not just the handrail that they can grab on, but the guards between here, so that they don't fall through there, especially like a small kid or something. So the ideal that we're looking for is these vertical spindles like this, where they're going up and down, and they're spaced no more than 4 inches apart, because the average human head is greater than 4 inches. So if your spindles are every 4 inches or closer, then they're not going to be able to get their head stuck through those between those spindles. What we do see sometimes is the horizontal barriers. So they may have like a 2x4 going across here or something like that. That is not considered acceptable because it actually encourages climbing. So like they would encourage a kid to climb up onto that and maybe climb over the railing or so on. So we want to see the vertical spindles in our guardrails. Here's another one where we can see that we definitely have 3 risers here. There's no handrail. Since this is less than 5 feet wide, we would be fine with having the handrail on one side or the other. It doesn't need to be on both sides, but we also have that elevated platform at the top of the stair that has no guardrail. And so that again, that magic number there would be 30 inches. So if that is greater than 30 inches off of above the next level below it, then it would need to have a guardrail in place. Even if it's not quite 30 inches, you can see that this one looks like it's, best practice would be to have a guardrail in place because I mean that would hurt if you fall off of that. It may not break anything, but it would definitely hurt to fall off of that. And so we would like to see a guardrail on that platform up at the top here. So right up here. Other slip trip fall items that we see, especially when we have like tile floors or concrete floors or something that could be slick if it gets wet, then we want to see non-slip mats at the entrances and exits. That way, if they have inclement weather where maybe it's raining, snowing, etc., when they walk in, they have a place to wipe off or dry off their feet before they step onto that potentially slick surface. So all of these places that you go to, kind of be cognizant of what the flooring is and whether or not they have those non-slip mats at the entrances and exits. Even if it's carpet, it's not a bad idea to have a mat for them to wipe off their feet before they enter into the building. Outside, we want to look at sidewalks, obviously looking for cracks in the sidewalks, elevation changes in the sidewalk that aren't marked, uh, potholes in the parking lots, especially if it's something where it's a potential for the clientele to be walking across that parking lot. Um, we want to make sure that there's no uneven cracks or potholes or things like that that would potentially cause somebody to trip and fall. This is also potential damage to their vehicles, so we want to make sure we get that pothole filled in and the parking lot resurfaced. So, like I said, the first part of the premises liability is pretty straightforward. It's pretty common sense. Just look around. Is there something that you think somebody could potentially trip and fall over? And that's really what we're looking at for that. The second part of the liability is a little bit more complicated. This is where we look at the life safety code. Now, the standard that we use is the NFPA, so the National Fire Protection Association, and they have a code that is the NFPA 101, which is considered their life safety code. And so that is the standard that we're looking at. This is for the number of exits, the type of exits, the marking of exits, emergency lighting, um, alarm systems. It's all of that stuff combined into this one really long, boring, tedious code that they have there. So for all the different occupancies that they come across, it lists out when they're required to have the emergency lighting, when they're required to have exit signs, when they're required to have fire alarms, how many exits they're required to have, and so on. So it's something that is definitely a lot more complicated because there's a lot of exclusions or exceptions built into the code. So it's something that we don't necessarily expect you to memorize or know all of the various codes and when they're accepted or when they're expected or when they're not. So we wanted to kind of cover some of the best practice ideas, get that kind of concept in your head so that you can get an idea of when these things are going to be required. So for starters, when you have exits, we want to make sure that those exits are usable. So we want them to be something that's not going to be blocked. This was actually in the rear of a retail store. So they had the sales floor up front. Then in the back, they had the little storage area where they could store any extra items that they had. And they were having problems with people breaking in this back door here and stealing stuff out of their storage while all the employees were up front in the sales lot or sales floor and had no idea this was going on. So their solution here was to lock and bar the door so that nobody could break in. The problem with this is now, if there's a fire, and say the fire's at the front of the building where they can't use that front exit, then they have to come back here to the back and they have to fight through this bar. They have to try and figure out how to get the bar off, unlock the door, and get out of that door. So that is not what we want to see for the exit door. If it is an exit door, it should be easily accessible. There should be nothing blocking it, and it's something they should be able to actually push right open. Uh, so the solution that we would like to see for them on this one would be something more along the lines of this, where we have the panic hardware. So this is something where they can permanently lock that door, and they don't even have to have a handle on the outside of that door. But here it's got the release bar that you can push to release this door from the inside. And these are actually set up to sound the alarm as well. So if somebody starts to walk out the door, then it sounds the alarm and alerts people that there's somebody opening or leaving through this door. So that would be a much better solution for uh, that problem that they were having at the retail store. Other thing to notice is that for exit doors, they should open outwards. We want to make sure that the flow of traffic outwards is not going to be impeded. If the door opens inward and you have a mass of people headed towards that door and they all hit at once, well then they're not going to be able to open the door because they're going to open it right into themselves. So we want to make sure that those exit doors are opening outward. Now, there may be times where there's exceptions to that rule. For example, I did one inspection. It was out on a pier out into the ocean. I think it was North Carolina that I was at, but we when you go out onto the pier, they had like a little store out there, and the door, if it were to open outward, it would block the entire walkway or entire pier on the side of the building there, and it would actually potentially push somebody off into the ocean. So they had an exception where they were allowed to open their door inward because they don't uh, have a high volume of people inside of the building, and because of that extenuating circumstance with the outward swing. So they had a special exclusion where they were allowed to have their exterior doors, their exit doors open inward. But generally speaking, you want your exit doors to open outwards. And you wouldn't be able to have like a place of assembly, like a bar or a restaurant or a club or anything like that, where there's a lot of people and have the doors open inwards. So that's just not going to work. Now, exit signs is a little bit trickier. The NFPA 101 Life Safety Code is very clear about when you have exit signs, they need to be posted above the door, not on the door. They need to be lighted. So that could be an external illumination. It could be an internal illumination. Um, the size of the letters is very specific. The color of the letters is very specific. They have a lot of details that are very specific. But then the question is, when do you actually need the exit sign? And that can vary drastically depending on the occupancy. So generally speaking, when you're looking at it, if you have a place where you have a lot of people that aren't normally there, that aren't necessarily familiar with the building, uh, that definitely needs to have the exit sign. So any kind of occupancy that would have visitors, like places of assembly, so like restaurants, bars, things like that, where there's people coming in that aren't necessarily familiar with the location, you definitely want to have those exits marked so that if there's an emergency, they can easily spot where to go and how to get out of the risk. If it's something that has very limited people inside, or the people that are there are regular, where they're going to be very like maybe like a warehouse type of operation where there's just not many people in there. That's something where you could probably get away without having those exit signs. The other kind of best practice that we look at is anytime that you have multiple doors and not all of them are exits, you want to make sure that you're marking which ones are the exits. So if there's only one door in the entire room and that is the exit, well then it's not as necessary for you to mark that as the exit. But if you have multiple doors, some of the doors go farther into the building and some of the doors go out, well then you want to make sure that you're marking those exits with those exit signs. But they need to be visible in low visibility, so that's why we need them to be illuminated. They need to be above the door, not on the door, but that way if you open the door, you can still see the exit sign. So for your standpoint, one of the best things you can do is just identify whether or not they have the exit signs. Then our review department can help you with the idea of whether or not they're required to have the exit signs. So when we get to that question on the multi-peril survey, it does ask you if they have exit signs, and you have an option for yes, they have them. You have an option for no, they don't have them, which if you mark no, we're expecting you to make a recommendation that they get exit signs. We have a no, but not required by NFPA 101 Life Safety Code, which means they're not there, but we wouldn't expect them to be. They're not required to have them. So there's no recommendation required for that. And then also they have one for yes, but they're non-functioning. So that means like they're not lit up or they're broken or they're hanging down, they're not properly installed, something like that. Or maybe it's just a paper sign that's not illuminated. There's something that's not quite right about it. That would be the one we would mark there. And of course we would want to make a recommendation to have that fixed. So when you're looking at the risk, just identify, do they have it? You maybe take a quick picture of one of those exit signs just to show that, yeah, they have exit signs in place, and that will be good for us. If they don't have it, you want to make sure that in the report you're marking, no, they don't have them, but then it's a matter of do they need them or not? And that's where our review staff can really help you out with the NFPA 101 Life Safety Code. Similar idea with the emergency lighting. Again, your big thing is just looking around, do they have it in the first place? If they're not, then we'll have to try and figure out whether or not it's required. So the best practice or the general guidelines that we want to follow for emergency lighting will be if this is an operation that is working after natural daylight hours. So if they work like nighttime shifts or anything that's later in the day where they're not going to have natural daylight, then they should probably have emergency lighting. If they have areas of this building that don't receive natural daylight, so like interior offices or things like that that don't have windows, don't have skylights, then they should have emergency lighting. That way, if the artificial lighting fails, they still have the ability to see to get out of that location. So that's kind of the best practice that we're dealing with. Now, there's definitely some exceptions to, like, for example, retail stores. They say that regardless of how late they're open, they don't need emergency lighting until they meet that 3,000 square foot, hit that 3,000 square foot mark. So those smaller retail stores aren't required to have emergency lighting, even though it would make sense from the best practice to have them. So for most of our customers of the insurance companies, they are perfectly fine with us making recommendations based on best practice rather than on NFPA Life Safety Code. The best practice is typically going to be stricter. It's going to require more protection than the bare minimum of the Life Safety Code. So that's the basics of liability. So again, it's just the slip, trip, fall, bump, and then that Life Safety Code. So it's really a common sense coverage. It's something that you should be able to feel comfortable with as you're walking around, identifying these things. But it is pretty basic. So now we're going to get into the operational exposures. So hopefully by now you're familiar with the fact that on our forms, all of our commercial lines forms, the first half of the report is going to be kind of universal. So it's going to be something that you should fill out every question, every time, regardless of what the risk is. The first half of the form should be completed. The second half of the form, though, for all of our commercial lines forms are called the operational exposures. So these are unique exposures that are developed because of specific operations. And so for that bottom half of the form, you're only going to fill out the sections that apply to your particular risk. So most of the time, the vast majority of that bottom half of the form is going to be blank on your report. The other thing that comes into play with this is when you go to print off the forms, if you're printing them off a la carte from the library, if you were to say pull up the multi-peril survey to print it off, it's only printing off the top half of that form. All of the operational exposures are then listed as supplemental forms that you would have to print off separately. So you would have to have an idea of what you're walking into, what kind of risk this is before you go there, so that you can know which supplements that you need to print off. So we're going to go through all of the different operational exposures from the multi-peril survey and kind of highlight what exactly are you going to be looking for these particular occupancies. So the first one that we have is it's just your basic habitational, so apartment, condo, homeowners association, or townhome. With all of these, regardless of which type of habitational it is, you need to give us some sort of unit breakdown. How many units are there total? How many units are there per building? We really want to know the details of that. If there's any kind of special units, we would like to know that. Like if there's some maybe like a handicap accessible unit or anything like that, then we'd want to know any kind of special unit breakdown as well. But definitely need to know the total number of units in the complex, and then the total or the number of units per building. And if there's different breakdowns, well, then you need to list out what all of those breakdowns are. So for maybe say there's 5 6-unit apartments, there's 3 4-unit apartments, and 2 5-unit apartments. So whatever it is, just make sure we get that idea of the breakdown. If each of the buildings have individual addresses, that's even better. If you can tell us which addresses are how many units. So that's the best way to give us that information. If they don't have individual addresses, then kind of give us an idea of give us an idea based on how you labeled the plot map. Did you say building 1, 2, 3? Did you say building A, B, C? How did you label it on there? And then give us an idea, okay, which buildings are how many units? We need to know how many paths of egress they have. So for habitational, the expectation is that they're going to have 2 separate ways out of this building. So most of the time, like if they have a common hallway, usually you will walk into the hallway and you can either go out the front of the building or you can go out the back of the building. But that hallway is going to lead to 2 separate exits out of this building. So out of the individual apartment unit, you may only go into the hallway, but then out of that hallway, you have 2 separate exits. Sometimes though, if they open directly to the outside, they would only need to have the 1 exit out of that unit. They don't need to have 2 separate units if they exit directly to the outside. Also, they could use like the decks or balconies or rear patio type exits. Those can be considered exits out of the units as well. So just give us an idea of how many egresses they have and what those egresses are. Just kind of describe it to us a little bit. Describe the fact that they have 5 apartment units opening into a common hallway, and then they have an egress at the front and an egress at the rear. Just a little bit more detail about those egresses is really going to help us out to figure out if they have enough exits out of this building. Then the laundry facilities is going to be one of the high risk areas for fire, especially with common laundry. These units, they're being kind of abused a bit. They have more people using them than you would normally expect for a standard washer and dryer. They have people that don't necessarily care about that piece of equipment because it's not theirs. So they might kind of be a little bit rougher with them. And then also you have a lot of ignorance factor where people, a lot of times in apartment situations, don't necessarily have the knowledge level. Maybe this is their first time out on their own. They don't necessarily know how to maintain the pieces of equipment. So when we're looking at these pieces of equipment, there's a couple of things we have to look at. First, we're looking to see, do they have signage posted reminding the tenants to clean the lint trap before and after their uses? We want to make sure that those lint traps are not building up with a huge load of lint that could actually catch fire and start the fire. So just maybe pop open a dryer, take a look at that lint trap. It looks like it's up, being kept clean. They're doing regular uh, cleaning out of that. And do they have the signage posted reminding them to do that? The other thing is fire protection. So fire protection, we're talking about fire extinguishers here. So for apartments, really fire extinguishers are not required until there are more than 12 units or more than 3 stories. So that's the only time that we're required to have fire extinguishers in an apartment. And then, even then, they're not required in the individual living units. They would be required in the common areas. The exception to this is if they have a common laundry facility, then we would have to have a fire extinguisher in that laundry room. So regardless of how many units it is, regardless of how many stories it is, if they have a common laundry, then they have to have a fire extinguisher in that room. So that tells you right there that NFPA has identified this as a high risk area for fire. So this is a high potential for them. So we want to make sure we get that fire protection in that area so they can quickly respond to any fires before they, maybe get too big and catch the rest of the building on fire. Other high risk areas are going to be any grilling. So when you're walking around, you're going to be checking to see if you notice any grills on the property. Try to identify, is it a gas grill, is it a charcoal grill? Maybe ask the insurer if they have any kind of restrictions in their leasing agreement. Do they require them to grill in a certain area? Do they restrict what type of grill they can have? So just kind of get an idea what their grilling policy is and whether it's built into the lease or not. But the laundry room is a big area of concern, so we want to make sure we're checking it closely. With apartments, that's another thing that I want to point out is that we're typically not going to get into the individual living units unless they happen to have one that is vacant that you can go in and look at as a representative of all of the units. If they are people living in these units, we don't get inside those living units. We will access all of the common areas of the apartment building to look at, but if they are occupied, we don't go into the individual units themselves. So that would be a question you want to ask right away is, hey, do you have any vacant units that I could take a look at? If not, I just need to see the common areas. So laundry room would be a common area, hallways would be common areas, maybe like a lounge area they might have, game room, exercise room, those types of things. Otherwise, again, we want to look at the grilling operations. We want to keep the grilling off of combustible surfaces. So we don't want to see grills on top of wood decks or balconies where they could potentially catch that on fire. We want to see it away from the building, so at least 10 feet away from the building so that we're not catching the walls of the building on fire, etc. So this one actually was on a wood deck and it had a roof covering over it. So all the hot air that's coming up off of that grill is catching in that roof and building up in the roof above it. So that's a big problem. This one they actually had, looks like a deep fryer that overflowed and flared up and melted the hose that connected the gas. And now the fire is coming directly out of the propane tank here. So this was a massive problem. Luckily, you can see that the fire department is there. They're spraying onto the tank right now, trying to keep it from spreading to other areas. But big time problem for us. Another one of those deep fryers that just the fire department's putting on a demonstration of how they can get out of control and how harmful they can be. The next item that we have is the auto service or repair. So for auto, we have 2 different sections. The first one is the auto service repair. The second section is sales or non-repair. So looking at the auto repair, the first thing we have to do is just identify what types of services do they actually perform. Because there's going to be different levels of concern depending on what they do. So is this just general mechanical repair? Are they doing body work? Or are they doing anything that might require painting? Are they doing things that would require welding or cutting? Is it just general servicing, like so things like oil changes or maybe tire replacing or anything like that. So there's different levels of risk involved depending on what their services are. So we really want to make sure that we're going through and identifying what type of service, what kind of repairs do they do. Then really nailing it down and going through. We have a list of all these different repair operations that they could be performing. So the best thing to do is to sit there with your contact and read through that list and just kind of check off all of the services that they provide. Because you could spend an entire day sitting there observing and not see a fraction of the services that they actually offer. So it's best to go through that with the person that you're interviewing and just say, do you do this? Do you do this? Do you do this? And so that you can get a comprehensive list of the services and repairs that they will actually complete. But then we're really focusing in on the higher risk equipment. So things like the parts washer, the hoists or lifts, the oily rags, the things that are going to create an elevated risk for fire is really what we're looking for here. So for the parts washers, we are looking at the type of parts washer that they have. We would like to see something like this, where it is a manufactured parts washer. This is designed for this specific purpose. And the purpose here is to have some sort of liquid that will cut through grease so that they can take an old part, they can take it over to this tub here, they can spray the liquid that onto the part and kind of scrub it down and remove all of the old excess grease and debris and dirt and so on, and get this part back into like new condition so that it can work properly. Sometimes that excess grease and stuff can cause it to gum up and not work properly. So if they can get it cleaned off and get it back to its original condition, then they can get that thing working again. Now, the big problem that we have is that most of the time, the liquid that they're using is a flammable solvent because that's just what cuts through the grease the best. So what we don't want to see is just like an open tub full of this flammable liquid that they're dunking the parts in and so on. We want to see something like this that's designed for the proper storage and recycling of that liquid. So here they actually have like a little hose that comes up and it sprays the liquid onto the part, but then it drains back down into this holding tank down below. So you don't have that open vat of the flammable liquids. We also have a lid that is stationed above the tank here. And on the back side, there's something called a fusible link. So this is basically just a little soft piece of metal that's holding this door in the open position. Now, if there's a fire, that little soft piece of metal should melt quickly, and then it should then release this door shut onto the tank here. So it hopefully contains and suffocates that fire so that it doesn't spread to the areas around it. So one thing you want to look at when you see these parts washers is take a quick look at that door. Does it look like the fusible link is in place? Is it being held open? Is it going to shut when that fusible link melts? We want to make sure that it's kind of like hanging over the tub here so that when it melts, it's going to close. If it's like leaning too far backwards and the fusible link melts, well, it's just going to open farther backwards. It's not going to actually shut on the tub itself. We want to make sure there's nothing blocking it, that there's no parts or stuff that are going to block that door from shutting onto the tub. But we also need to pay attention to the location of the flammable liquids parts washer. So does it make sense? Does this look like a good spot for that parts washer? For example, if you look at this one on the right-hand side, we see that right next to it, there is a bench grinder. Well, the bench grinder, when it's being used, is throwing off like sparks and molten metal all over the place. So we don't want to have our vat of flammable liquids right next to something that's going to be throwing off sparks and molten metal. That's just asking for an ignition source or something to catch that flammable liquid on fire. So that is not necessarily a good spot for that. So just kind of keep in mind, be cognizant of what's around the parts washer to see if this is a good location for it. For hoist and lifts, really, we're just looking to prevent collapse. of these. So if you're lifting, a couple thousand pounds of vehicle up into the air, we want to make sure that it stays up in the air. We don't want it to fall down and crush somebody or damage the vehicle or damage something else below it. So we're just looking, do they have any kind of safety devices in there to prevent that from collapse? So like on this hoist over here, we have the main column that's lifting it up, but then we have a safety column over here. So it's got like a kind of like a latch system or a ratchet system. So as it goes up, it's got like a little lever that's kind of, as it goes past each point, it kind of flips up, and so it's got that fail safe. So if it falls, it's only going to fall that far. So it kind of it gives it that security and protection. So you just want to check on. There should be a service tag on these. They should have them serviced annually so that they can make sure that they're going to continue to work in the proper way. Make sure that the safety catches are in place and everything. So you should see a service tag on the hoists or lifts to let you know that they've been serviced. Oily rags are a big time concern. This is for auto repair, but this is also for like commercial cooking. We always want to look at oily rags and how they're storing them, because most of the time they have like a laundry service that will come and will pick them up and take them off to be washed. Most of them, especially like shops, they're not going to do their own laundry. They're at the shop, so they have a service that comes and picks them up, washes them, and brings them back for them. So how are they storing those rags until they are picked up for laundry? What we want to see is a metal can with a self-closing lid. That way, if those rags ever self-combust, they will be contained inside of that metal can, and the lid will help to suffocate and stop that fire before it gets big enough to spread to the areas around it. What we don't want to see is just like random, like these have little plastic bags. Sometimes you'll see that they'll have like a mesh bag that the laundry service uses to pick them up and deliver them. That's going to allow air into those rags, and it's going to cause kind of abet, or it's going to aid the fire process. So if they do start to self-combust, that's just going to fuel that fire, and it's going to cause it to burn even faster. So we want to see them in these metal cans with the self-closing lids. For the auto sales or the non-repair operations, what kinds of services are being rendered? Because this one can be pretty wide reaching. So it's basically anything that has to do with autos that's not repair. So, what kinds of services are they? Are they doing sales what types of vehicles are they selling? What type of dealers? Is it used? Is it new? Is it consignment? What type of sales is it? And then if it's non-repair services, what is that? Is it a parking facility? Is it a limo service? What kind of other services do they have? With all of them, though, we want to kind of get an idea what their scale of vehicle transportation is. Do they, pick up vehicles from auction? Do they get vehicles from other dealerships? Do they have vehicles as part of? Are they a livery service where they're actually driving vehicles as part of their service? So we want to get an idea of how often they're on the road, how far they go, who's doing the driving, etc. And then vehicle key location is very important. We want to make sure that those vehicle keys are secured to prevent the theft of these vehicles. And then looking at the lot security, make sure they have proper lighting, proper security. Do they have any kind of fencing around the lots, or any way of preventing the vehicles from leaving the lot when they're not supposed to? So with the vehicle key location, we're looking for them. We would like to see them in a lockable cabinet or box so that they can be locked up and secured. A lot of times you'll see them just on a pegboard on the wall where they're just open. Anybody walking by could grab one of those keys and take off with it. So we want to see that those keys are securable and something maybe in a drawer or in a box on the wall, but it needs to be something that they can lock up and secure those keys. And then just looking again at the parking lot itself and trying to identify what kind of security measures they have in place for those vehicles. One of our newest operations is the cannabis operation. So as More and more states legalize the use of cannabis, whether it be for medical purposes or for recreational purposes. We're seeing more and more cannabis operations. And we have some clients that are specialists where that's all they write is cannabis operations, but we also have some of your kind of mainstream insurance companies delving into the cannabis operations just because they're becoming more and more popular and more prevalent. So we had to come up with some questions to address the concerns that we have with a cannabis operation. So the first thing we have to do is just identify the type of operation this is. Because there's going to be different risk levels depending on what they're actually doing. Are they a dispensary? Is this like the store basically where people can go and actually buy the product? Is it an extraction like laboratory where they're taking the cannabis and they are breaking it down and extracting the CBD, or putting uh, getting this into the essential oils and things like that, where they can then use those for other products, maybe the edibles or things like that. But that extraction process is going to be very complex. It needs to be very controlled. It's typically going to have a lot of chemical exposure and things like that, where they are a potential for fire, potential for explosion. So we really want to make sure that we're identifying that that is an extraction process. The grower, this is typically going to be a lot more like a big warehouse where they're going to have plants growing throughout the structure. They're going to have a lot of extra lighting, and so a lot of extra electrical exposure, and it's going to be a moist, damp environment. So you're going to have a lot of extra electrical in a moist environment. So you have potential there for corrosion exposure to the electrical. So we really want to pay attention to the electrical, especially when you're dealing with those growers. And then the processor, that's where they take the cannabis or the CBD, and they actually then convert it into the final product, whether that be like a cream or a balm that you're rubbing on, or edible, or whatever the final form or product that they are actually using. That's where they would actually process that and turn it into that, so that it can be sent off to the dispensary for the sale. So we want to make sure we're identifying which of those operations. They may have multiple operations within their facility, but which ones do they actually perform? And then listing off all the chemicals that we identified at that location, especially for the extraction, because there's all kinds of different processes now for performing that extraction process, getting down to those essential oils. And there's all kinds of hazardous chemicals involved with that. So we want to make sure that we're identifying what chemicals we can see at that location. But then security is a big issue with cannabis operations, because it's a high demand product. It's a highly cash oriented business, because these are all like state approved. They're not federally approved. It's very difficult for any kind of credit card purchases. You may have some kind of localized bank or something like that, or credit union that might be able to process credit purchases from these facilities. But generally speaking, you can't have a credit card because it's not federally approved. It's still illegal on the federal basis. So this is typically going to be something that's high cash product. So we want to make sure that they have proper security in place for not only the high demand, high exposure product, but also all of the cash that's coming with it. So we're looking for things like a safe on the facility, looking for some kind of security vault, whether it's for the product or for the cash, a cage, especially for the product. And then looking at how are they transporting this product. Do they have special security procedures in place? Do they have two operators in all vehicles? Do they have armed people with the vehicles? Do they vary their routes? Things like that. So we want to know, just identify that they are taking procedures to protect against theft with their transportation. Some of those questions can get a little sketchy sometimes, though. And if the insured is not responding well, you can always kind of back off of that and just put in your report that they were not comfortable answering these transportation security questions, or they weren't comfortable with the money security questions or something like that. But as long as you're identifying that you asked the questions and they just didn't want to give you those answers, that's fine. But photos can go a long way with all of our reports. Identify that they have the safes. Are they bolted and anchored? Are they small enough that they could potentially be removed? What kinds of security do they have in place? What kind of vaults? What kind of cages? What's the electrical look like in the growing operations? Those types of things. Give us those overview photos, but also get into the specifics of the higher risk areas. Gas cylinders. We have all kinds of different compressed gas cylinders out there, all different types of gases. They have different functions or purposes. So we need to know what kinds of gases they have, because obviously there's going to be a huge difference between a non-flammable gas and a flammable gas, and something that could explode and something that's just pressurized, something that might be toxic. We need to know what types of gases they have. The good thing is that most of these manufacturers will use a color coding system to identify the gases in the tanks. So you can usually tell from a distance what kind of gases you're dealing with just based on the color of the tank. Or like usually sometimes it's just the top or the cap of the tank that is color coded. So, you have like green would be oxygen, red would be the acetylene, blue would be argon. You have these different colors for the different gases that you're dealing with. But we want to make sure we're identifying all the gases that they have, and then how are they securing those cylinders. So these cylinders, they tend to be the very real tall, skinny metal tanks that they're pretty awkward, and they're vulnerable to like tipping over and falling. If you tip a tank over and it breaks the little nozzle off of the tank, now you have all this high pressure gas escaping through a small hole in it, and it's like a little torpedo that takes off through your facility. So we want to make sure that we're securing these in the upright position so that they're not going to tip over and fall. So that can be chaining, strapping, lashing, putting them in a rack or stand, whatever it is, just as long as we're keeping them in the upright position. You'll see a lot of times they try to just get away with putting the little collars around the nozzles at the top to say, oh, well, if it tips over, this collar is going to protect the nozzle. Well, it's still not quite what we're looking for there. We want to see them actually strapped or chained or some way to secure them in the upright position so that they don't ever fall over. Once we identify the gases, then we can look at the separation of those gases. So we want to make sure that like oxygen and argon are separated from any accelerants. So if you think about like the most common time that you see oxygen, it's with acetylene. Because when you put oxygen and acetylene together, the two gases mix together and they form a vapor that will burn so hot and so violently that it vaporizes metal. So if you have your tanks stored together, you don't want to have your oxygen right next to your acetylene, where those two, if there's a fire in your building, they're going to burn so hot and violently that it vaporizes metal. So for those extra tanks, all those storage tanks, you want to make sure that you're keeping those, like the fuels, like oxygen, things that are going to aid the fire, separated from the accelerants, the ones that are going to make it burn even hotter and faster. For the basic idea here, we're looking for a 20-foot separation between the oxygen and the accelerants, but that's not always possible. There may be space limitations and so on. So if you can't get that 20-foot separation, then we need to at least have a 5-foot tall stainless steel barrier with a half-hour burn rating between those two types of gases. Some way of separating those so that if you have a fire, those two gases aren't going to blend together and form an even worse fire. And finally, we just want to identify what types of operations are they doing? What type of welding are they doing? Is it arc welding? Is it MIG or TIG welding? Is it oxygen acetylene? So, arc welding is just using the basic electrical arc to vaporize the metal. And then as soon as you release the electrical arc, the metals, the gases that you formed, the vapors, they'll re-solidify together, merged as one. So that's the most basic concept of welding is the arc welding. But then you can get a little bit more advanced to the MIG or the TIG welding, where now you're using an inert gas to provide kind of like a bubble around the weld. So it's still using electrical arc to vaporize the metals, but now you're putting a non-flammable gas bubble around that weld so that it protects it and keeps like dirt and debris and stuff from entering into that weld. So now when your metals vaporize, it's just the metal particles that are mixing together and resolidifying. You don't have extra debris in there. So it's a cleaner, stronger weld when you have the inert gas welds. And so the M and the T, that's just telling you what kind of filler metal you're using. So are you using manganese or are you using tungsten as the filler metal in between the two pieces that you're trying to connect? And then the oxygen acetylene, that's typically going to just be a cutting device. It's a torch that usually will just be used to cut through metals. It can be used for welding as well, but it's a little bit sloppy and dirty. It's not as efficient as arc or MIG or TIG. So you would typically only see it as like a cutting device. But generally speaking, we want to make sure that those tanks are secured in the upright position, strap, chain, lash somehow. But you also want to make sure that they're strap, chained, lashed to something, something stable, something secure that's not going to tip over. It looks like these are actually just chained to each other. So now if one of them starts to tip, it just pulls the other one over with it. We want to make sure that they're chained like to the wall or something like that that's going to actually hold them in the upright position. And then here we can see that we have zero separation of tanks. We have red, which is acetylene, we have blue, which is argon, we have green, which is oxygen, all mixed in together. There's nothing securing them. They're just freestanding here. You have like a trailer here that looks like it was backed into place, so you could very easily bump into any one of those tanks and cause basically a fireworks show where they start to all tip over, start to bust, start to shoot off throughout the building, and then you have all those gases mixed together. So if there's a fire in this facility, all those gases are going to be mixing and causing a very dangerous fire. So that's a very improper storage of them. We want to see something more like this, where here we have two different systems. The one on the right, they actually have a cage set up, so they put in, they separate them by gases, and they have the barrier between the gases to separate the types. But then they're in these locked cages, so that you can't bump into them, you can't tip them over. The one over here on the left, this one is another good setup. So we have these poles that are buried into the concrete, so they have something solid and to anchor them to. We have them labeled as full, empty, full, so that they have the separation. They have the stainless steel barriers between them for the separation of the gases. You have your no smoking. You have your pylons to protect from vehicle contact. The only issue that we see with this one is the fact that there's no tanks being used or stored there. So we know that they have tanks because they went to the effort of installing the system, but they are not utilizing it. So that just begs the question of, well, where are all of their tanks right now? Are they, inside freestanding like this? Why aren't they utilizing the system that they put into place? But here we see, here's a MIG welder. So we have the gas tank on the back. So the argon's on the back there. That's the inert gas. It's a non-flammable gas, but connected up to the arc welder so that they can do the MIG welding. And then over on the right, we have the oxygen acetylene torch. This is the only time that we will allow these two tanks to be next to each other without any kind of separation, is when they're actually strapped to the cart for the torch operations. So you can see that they have the green hose and the red hose, and the green hose goes to the green tank, which is the oxygen. The red hose goes to the red tank, which is the acetylene. And so those two gases are kept separate all the way until the end point here. Right here where the flame is, that's the only time that those gases are mixing together. So daycare can be a pretty common sense type of exposure, basically just anything that could harm the children, and we need to make sure we're protecting against that. But when we're looking at it, first and foremost, we just have to identify the type of daycare. What is this, a commercial daycare? Is it like a private, like in-home daycare? Is this daycare at like a religious facility, like or school, you know, what kind of daycare services is this? You know, are they just taking students, you know, children from all over the community, or like sometimes you'll see like these bigger offices or bigger companies, they might have their own daycare built in within their company in their office location for their employees only. So it's a kind of a smaller scale, limited version of daycare. So we want to make sure we're identifying what types we have. Then how many children are there? You know, what is their license? How many are they allowed to have, and how many do they currently have? Uh, get a breakdown for ages. You know, how many infants do they allow? How many crawler walkers? How many toddlers? How many school age? You know, just get an idea of how many they're allowed on their license, and then you know get an idea how many they currently have at each one of those age levels. Do they have any kind of license? Or, you know, who's actually supplying the licenses for them? Is it a state license, a county license? Is it done by the municipality? You know, who's certifying them to perform this daycare operation? And then, do they have any kind of other qualifications? Are they CPR trained? Are they medically licensed, where they can actually administer medications or things like that? Or do they have any other licenses or certifications where you might see this as something like a troubled youth care, or maybe like a handicap or physical needs uh, care, where they might have to have extra certifications in place or extra licensing for the handling of the care recipients, to make sure that they are properly handling them and moving them, and etc. So those are some of the extra types of care provider qualifications we might see. Generally speaking, you're looking at like the playground area. Is it well maintained? Does it look like there's any sharp points? Does it look like the wood is rotting, or that it's got splinter potential? Or you know, are there any components that are potential for pinch or cut? Do they have proper flooring or fall protection below it? You know, something like this one you can see is that kind of rubberized matting. So it's like the recycled tires that have been crushed up and they put into this flooring, where it's now kind of a bouncy, rubbery floor. Do they have like mulch or pea gravel or something like that that would cause a softer fall? We don't want to see just that hard dirt ground or hard concrete or anything like that where they could fall on that. But otherwise, you know, just again looking for common sense. Is there somewhere where they could fall and hurt themselves, or something that they could cut themselves on or pinch themselves on? It's a really pretty straightforward idea. One of the more unique items that we look for with the daycare operation is the bottle warming. So if they have infants, then we need to check out how are they doing their bottle warming. Are they just running it under tap water? Are they using an electric bottle warmer? Are they using like a little crock pot like this one, where they maintain a hot water at all times so they can just drop the bottle in? So, you know, we have a couple of clients that specialize in daycare operations, and so like those accounts, you'll see in the idiosyncrasies that for if they see a crock pot or a bottle warmer, they want a recommendation to have that removed, because they don't want any potential for a child to, you know, accidentally pour that onto themselves, and you know, maybe grab the cord or something and pull it down onto them. So we want to make sure that we're identifying how they're doing their bottle warming in those daycare facilities. Flammable combustible liquids, of course, you need to identify whether it's flammable or if it's combustible. So what types of liquids are we dealing with? So there's a huge difference between a flammable and a combustible. So that difference is going to be the flash point. At what point does it ignite? What temperature does it ignite? So if you have like a bowl full of gasoline, and which is a flammable, it has a very low flash point. If you take that bowl full of gasoline, you light a match and throw the match at it, well, it can actually erupt into flames. It's such a low flash point that it will ignite easily. If you have a bowl full of oil, well, that's a combustible. It has a much higher flash point. So you take that match, you light it, you throw it at it, it probably will not catch fire because it's not hot enough to ignite that oil. Now, once it does ignite, it's going to burn, and it's going to burn hot. It's going to burn for a long time. But it's just a point at what temperature does it actually ignite and flare up. So there's a big difference between the flammable and combustible. So you need to identify what types of storage or what types of liquids they have, and then how are they actually storing those flammable liquids? Do they have special flammables containers, uh, that are designed for the storage of those particular flammable liquids? Do they have cabinets? They need to be the specific flammable cabinets. Are they just being stored out in the open shop area? Do they have a flammable storage room? It's a specific room that's designed for the flammable storage. If they do have the flammable storage rooms, it needs to be, it needs to meet all of the criteria of that room. So it has to be 2-hour fire rated construction, which means it's probably some sort of masonry, well, like concrete block or something like that. It needs to have a ventilation system built into it, so that if there's any kind of vapors released from the storage, that's going to be ventilated out of the structure, and that it needs to have some sort of spill containment. So that room should either have a recessed floor, so that if there's a spill, it's not going to spill out beneath the entry door out into the main area, or just some sort of lip at that door to keep it from spilling out into the outside area. And there cannot be any outlets or switches or potential electrical arcs or sparks inside of that storage room. So there's a lot of criteria involved with that storage room. It's a pretty serious undertaking for that process. If they have drum storage for like mass volume type of storage, so where they have the big drums of the liquid, then we need to look at, are those drums being grounded? Are they connected to the ground in some way? So maybe they have the piping that goes into the ground, that they're connected to those pipes, so that there's no electrical buildup or charge buildup on those drums that could possibly arc or spark. And then bonding is like when you're trying to transfer liquids from the drum to maybe a smaller container. This is where you can actually connect up those two devices. So you can have like a little wire with little clips at either end. So you connect one to the smaller container and one to the drum, so that you have an easy flow of electrons through the two devices. So you don't have a buildup of opposing charges on the two different containers, and potentially arcing or sparking, because you don't want any arcs or sparks when you're dealing with flammable storage. So what we want to see is some sort of securement or somewhat proper storage of those flammable liquids. So something like the flammables cabinet here. This is not your standard office cabinet where it's just the standard like thin gauge metal cabinet. This is a flammables cabinet. So this is a double walled cabinet. It's got the heavier gauge metal. It's got some sort of spill containment at the bottom here, so that you don't have stuff leaking out. Probably it should have some sort of ventilation system, probably on the backside there, that if there's vapors that are released, they're going to be vented out away from them. So we need to see something like that. It should be either the bright yellow or bright red to identify that, hey, this is flammables. That's what we'd like to see, or maybe the storage room. What we don't want to see is just the stuff being stored out in the open, especially like here we see all these drums of flammables and like gas right next to an operating torpedo here. So there's a flame at the end of this torpedo here that's heating the area around it. And all they have is this little thin piece of plywood that's protecting these cans of flammable liquids from that open flame. So clearly not a good way of storing their flammables. Now, I did have a question going back to the daycare here. Somebody asked how, or what's the recommended way to warm the bottles, and that is just to run them under the warm tap water. You don't have to actually get the milk hot. It just needs to be warmed up to like basically room temperature. And so they can use the warm tap water to run it under that until it gets to the desired temperature. That is the preferred method for heating the bottles. Next, we have the fuel storage tanks or dispensing. And so once again, just identifying what types of fuel we're dealing with. Are we dealing with oil? Are we dealing with gas? If so, is it diesel? Is it gasoline? Is it propane gas? What kinds of gases are we dealing with here? So when we have fuel, what type of fuel is it? And then what kind of tanks are they storing that fuel in? Is it a steel tank? Is it a fiberglass tank? Is it a combination of steel and fiberglass? Is it above ground? Is it below ground? Just really give us an idea. Also, the size of those tanks. How big are they? What's their capacity? But then we need to look at the tank protection. So this is where some of these terms may not be familiar to you. So things like diking, that's where you have like basically little walls around the tank. It's usually, it protects from vehicle contact, but it also will help with spill protection. So if you have a leak, that diking is going to contain that spillage. Curbing, that's just where you basically lift it up off the parking level so that, hopefully the vehicle will hit the curb and stop before it hits the tank. Pylons are just those posts that stick up out of the ground, so they're usually metal or concrete. Again, it's going to protect it from vehicle contact. And then cathodic protection, this is the one that a lot of people don't know or don't understand. This is for those underground steel tanks. So steel, once it's put in a moist environment, will corrode over time because it's going to be releasing more electrons than it's taking in. So that's going to cause that steel to kind of weaken and crumble over time. So what they do is they actually will do, they'll put a sacrificial cathode or a piece of metal that they can sacrifice next to the tank, and they'll actually connect it up. And that cathode is made of some sort of metal that is actually releasing electrons faster than the steel. And so they will capture those electrons off of the cathode and run it across or enter it into the steel. So yeah, the moist environment is causing the steel to emit electrons, but it's also gaining more electrons than it's emitting. So it's going to protect it from that natural corrosion process. So it's a very complex idea. It's something that unfortunately you can't really see because it's an underground system. So it's something that if you have an underground tank, you can ask the insured if they have cathodic protection in place. If they kind of give you that deer in headlights look of like, what in the world is cathodic protection? Well, then we would just mark no, they don't have it. If it's something that they've gone through the time and expense of installing a cathodic protection system, they're going to hopefully understand that question and know what cathodic protection is. And then finally, we just need to check if they have any kind of procedures in place to check for leakage testing. The environmental exposure is extremely costly. It's a long-lasting, expensive claim if they leak their contents out into the environment. So we want to make sure that they have some way of identifying these leaks so that they can get them resolved before they actually get down into the ground and cause pollution. So it could be electronic testing. Most of your more modern facilities will have some sort of electronic testing where they'll have gauges built into the tank that will tell them, okay, this is how much you dispensed, this is how much you still have. So that's matching up. There's equal amounts. Or they'll say, okay, you've only dispensed this much, but you've lost this much. So that means you have lost this much more than what you dispensed, so it must be going somewhere else. So check around, make sure it's not going into the ground. Stick testing, that's just a very minimalistic, simplistic way of doing it. That's where you take a stick, you dunk it down into the tank, pull it up, see how high the wet level is, and then you kind of gauge how much fuel you have in the tank based on how much of the stick is wet. But either way, you're just trying to identify if there's a leak, making sure that you're matching up how much you're dispensing versus how much you have left. So we're just looking around at the tanks. Okay, how are they being protected? Making sure that you're not going to have vehicles running into them. Making sure that you have some sort of like spill containment or a way of catching the leaks if they do have a leak. Sometimes you'll see that there's no spill containment below it, but it's a double-walled tank, so that if the interior layer were to corrode or rust or leak for some reason, the second layer would then catch the excess. sometimes they're inside the diking, so it's like basically a tub that they're sitting in. So if it does leak, it's going to fall into that tub, and the tub's going to catch it, so it doesn't go into the ground around it. But we want to just check, okay, not only is it protected from vehicle contact, but then also are there any signs of spillage around it? So here you can see a bunch of like kitty litter on the floor where they're trying to soak up all the spillage from this drum here. So earlier we talked about most of the habitational, which is the apartment, the condo, the homeowners associations, all that stuff. Now we're looking at specifically hotels, motels, and dormitories. So these are going to be classified slightly differently. So we need to identify the type of operation. Is this a franchise hotel? Is it a small like mom and pop hotel? Is this a Verbo, where it's a vacation rental by owner? Um, is it, what kind of rental types do they have? Are they hourly rentals, daily rentals, weekly rentals, long-term, like monthly rentals? Well, obviously that's going to change the types of clientele that they have and what their exposures are. How many rooms do they have? Do they have any handicap accessible rooms? Do they have smoking rooms? Do they have non-smoking rooms? Those are the types of things that we want to look at for these hotels or motels. And then finally, what kind of amenities do they have? Do they have swimming pools? Um, do they have restaurants? Do they have breakfast bars? Do they have alcohol bars? You know, what kinds of extra amenities do they have, like an office or a business center? You know, if they have a pool, then we need to make sure that they have all the proper pool protections in place, where they have like the non-slip edging, they have the pool depth markings, they have the Virginia Graham Baker drain device on there to prevent you from getting trapped into the drain. So we want to make sure that they have all, you know, the life-saving equipment, the hooks, the life preservers, all those things, the emergency phone, all the stuff that we would look at for any pool anywhere. We want to make sure that they definitely have that here in the hotel. But just really that those amenities, you know, listing all of the different services that they provide will really help to identify the risk level involved with that particular hotel motel. For manufacturing processes, this one really needs to know what they're manufacturing and how they do it. So, you know, if you remember on Tuesday, we talked about during your description of operations, you should be walking us through the process from beginning to end. So from the time the raw material first arrives at the location, what all does it have to go through before it leaves as a finished product? That's especially important for manufacturing operations. So really make sure that you're identifying and explaining that process here so that we can see the total scope of what they're doing and what their exposure is. But then we want to focus in on the types of materials involved. Are these your ordinary combustible materials, or are they some more hazardous materials? Are there chemicals used? Are there hazardous metals or other types of materials being used? And then where are those materials being stored? Are they being stored in the same room as the manufacturing process? Are they in their own separate room? Are they stored on racks? Are they stored on pallets? Is it just solid pile on the floor? You know, do they get deliveries daily of just the amount that they need for that day, or do they get bulk storage and, you know, just use it up over time? So that's going to really, you know, affect the exposure to the structure and to the employees working there. So we want to make sure that we're identifying what materials and how they're being stored. So we're really focusing on the more hazardous materials, looking for things like the flammables, the corrosives, the toxins, you know, anything that could be dangerous. We want to make sure that we're identifying that, and, you know, looking at labels on the warning labels on the different products or the different materials to see if they do have any of those hazard labels on them. Mobile home park, this one tends to be a little bit common sense. We're looking at what size and type of park. You know, what kinds of vehicles? Is it RVs? Is this mobile homes? Is this modular homes? You know, what kind of park is this? And then what size? How many lots do they have? How many spaces do they have? Do they provide electric? Do they provide waste services? Do they provide water? What kinds of facilities do they have on there? Do they have any common buildings? Things like uh, uh, maybe a store or an office building on site or a maintenance shed or anything like that on the facility. And then looking at the public liability, what do they have, like a speed limit set throughout the property? Do they have sidewalks? Or a lot of times with these mobile home parks, you'll see that it's just the roads and people are walking on the roads, same roads that people are driving on. Do they have any kind of lakes or ponds or swimming holes? Or if they have lakes or ponds, are they designated for swimming, or do they have markings saying no swimming, no boating, no fishing, etc.? What kind of lighting do they have throughout the facility? Do they just have street lights? Do they have adequate lighting so that you can see for safe walking or safe driving throughout the property? And do they have any other amenities like playgrounds or basketball courts or volleyball courts or anything like that that could be a potential area for injury? And then severe weather, since these are not permanent foundation structures, we want to make sure that they are prepared for severe weather. Do they have like anchors or tie downs for the units? Do they have evacuation procedures in place? Do they, what kind of protections have they put into play for severe weather exposures? But really, just again, it seems like common sense stuff. Is there places where people could trip and fall or get hurt or drown or get hit by vehicles, things like that? We want to make sure that we're putting up warning signs or protections in place for all the people that might be at this location. Spray applications in booths or rooms. So just like everything else, we need to identify the types of sprays that they're doing, because there's a huge difference between a flammable spray and a non-flammable spray. With both of these, you're vaporizing this material, so it's becoming more combustible just in the fact that it's vaporized. But if it's a flammable to start with, like a paint, then you're just vaporizing a flammable and just asking for an explosion. If it's a non-flammable, well, even the vaporizing of it can cause some potential for explosion if there's enough of that vapor pressure, but it's not as likely. So it's a much safer process. So you need fewer controls in place for that non-flammable spray. So that's the first and foremost. What are they spraying? And then second, where are they doing this spraying operation? Are they just doing it out in the open room where it's exposed to other operations? Are they doing it in a fully enclosed manufactured booth? Or is this some kind of modified, or something that maybe they built their own, where it's a three-sided or other, maybe like a curtain wall or something like that, where it's not truly a manufactured booth? If they have the manufactured booth, there are several requirements that we're looking for here. So the booth must be vented with filters in place. So we want a way of getting rid of all that extra vapor before it builds up and explodes. So they should have that ventilation system where the actual motor for the ventilation system is outside of the booth, but then it sucks the air out of it, whether it be a cross draft or a down draft or an up draft. There's some way of sucking the air through there and sucking it through filters so that it catches most of that overspray in the filters, so that it doesn't just pump it out into the atmosphere. There should not be any kind of electrical outlets or switches or devices inside of this booth. We don't want anything that could potentially cause an arc or spark, because we don't want to ignite this flammable vapor that's floating through the air. Should be a non-combustible construction. So most of the time it's made out of metal, um, because it's non-combustible and because it's easy to clean. You can do it out of masonry, like concrete block or brick or something like that, but those tend to be more porous and they may trap some of the vapors in the wall materials and make it harder to clean it up, and you have the buildup of these then flammables on the walls. So most of the time we see that it's the metal construction because it's just easier, it's cheaper and it's easier to clean. Now there is a requirement. The NFPA says that there should be an automatic suppression system inside of that spray booth. So it's a chemical spray that can spray down onto the booth if there were to be a fire inside there. This is one of those areas that a lot of our clients are kind of indifferent to. They don't necessarily care if there's the suppression system or not. They kind of say, that's kind of overkill. That's not required. But the NFPA license or the NFPA code does say it should have the suppression system. So we have, for example, auto owners, which is our single biggest client in our company. They have given us that get out of jail free card. They've said specifically, we do not care about the suppression system. We do not want the recommendation for that. So we have that in writing from them. So for auto owners, don't worry about it. If they don't have the automatic suppression system, no problem. We're not going to make the recommendation. For anybody else, they haven't given us that get out of jail free card. So we have to cover ourselves and protect ourselves and go with the letter of the law of NFPA and say, yep, if they don't have the suppression system, we're making a recommendation that they get that suppression system. So looking at the booth, we want to check the construction of the booth. We want to see that fully enclosed, metal construction, the non-combustible construction. Something like this where they have like the curtain walls, this would only be acceptable for a non-flammable spray. So, maybe something like the rhino lining on a pickup truck bed, something like that, where it's a non-flammable material and it's usually sprayed out in larger particulates where you're not going to have that explosion or exposure. So really all you're concerned about is overspray. You don't want it to get on the surfaces around you. That's where something like this curtain wall could come into play and be acceptable. But if it's a flammable, then this would not be acceptable. We would need something that is fully enclosed, non-combustible like this. So we have walls on all sides. You have the doors that will close on the ends here. You have the ventilation system back here with the filters. We have the vapor-proof lighting so that you're not going to have any kind of arcing or sparking from the lights causing ignition. There's no outlets or switches anywhere inside of this booth. It does not have the suppression system in it, so that would be a recommendation that we would need to make. But otherwise, this is meeting the requirements of the spray booth. For this one, you can see it looks like they just have standard drywall on the wall, so that would be something that would absorb the overspray, so it's not necessarily ideal. But the big concern that we have here is that they have this electrical cord that they have run into this facility because they were actually, they were bored in there. They wanted to hear music, so they ran an electrical cord from outside into the booth so they could play their music. Now, there's a reason there's no outlets or switches inside of the booth, so there's the same reason to keep that radio outside of the booth. We don't want anything to possibly ignite those vapors. Warehouse or storage, what kind of commodities are being stored? This is especially important if they have a sprinkler system, because we need to make sure that the sprinkler system can handle a fire based on the types of commodity, because you have a lot more material to burn. So we need to make sure that what kind of material is it? Is this ordinary combustible like a paper or wood, or is this something like a plastic that's going to burn differently? It's going to be a more hazardous burn, possibly a hotter burn. So we want to identify that they have that in there. So what kind of commodities are being stored, and then how are they being stored? Are they being stored in rack storage? If they have rack storage, are the racks secured? Are they anchored to the floor? Are they anchored to the wall? Are they anchored to the ceiling? Something to prevent them from tipping and falling over. Are they using solid piles, or just kind of stacking things on the ground on top of each other? Are they using pallet storage? If they are pallet storage, how many pallets high will they stack it? How high will they go? And then, do they have any kind of industrial trucks or forklifts inside of this facility? If so, how are they powered? Are they battery powered, diesel powered? Are they propane powered? And then, do they have any kind of protection in place to stop those industrial trucks from running into the racks? So it may be just some kind of pylons at the corners. It may be like a magnetic strip. Sometimes you'll see that they have the magnetic strip running down the center of the aisle, and so that fork truck can't veer off of that magnetic strip. So that's how they're protecting from contacting the racks. but we just want to see some sort of protection in place to keep them from running into the racks and knocking over the racks. So identifying the materials that are being stored. Here we have a bunch of wood pallets, so that's going to be really increasing the fire load inside of the structure. So we want to make sure that we're identifying that so that we can see if they have the proper sprinkler protection for that. And then again, looking at the industrial trucks. And the final operational exposure we have here is the woodworking. So for woodworking, it seems pretty simple. Just identify the types of equipment that they're using. Could be saws, drills, lathes, sanders. They all have different functions, different exposures, different levels of dust creation. So we want to make sure that we're identifying the different types of equipment that they have on the facility. You may need to just sit there and ask the risk what types they have, because you may not be able to identify them just by looking at them. And then the big thing is just looking at the dust collection. How are they collecting the dust that is created? How often are they doing the dust collection? Is this something where you can see like there's a crusty layer of dust on all the surfaces, or does it look like just a real thin film where you can tell that they're doing a regular cleaning of these surfaces and getting rid of all that dust and debris? So you can see from the surfaces of the equipment, you can get an idea. Okay, of course, there's going to be some dust on it. Just that's what happens when you use these equipment. But there's a big difference between a fine film of dust and then a thick layer of crusty stuff that looks like it's been there for a long time. And then looking at the dust collection equipment, so like here you can see that they have a pretty elaborate system where there's these hoses that are coming up to the pieces of equipment and attaching right here by the blade. So as it's creating the dust, that vacuum is sucking that dust up and taking it away to the collection system. But then we have to ask, okay, where are they actually taking that to? So here we see this is just like a room vacuum. So it's got like the hole here is just sucking the air in general and then capturing the dust into the bag. This one's a much bigger, much more elaborate system where all the dust is being collected and piped out to this big silo where it's being held until they can come in here and empty it into trucks to be taken away for resale. So, there's different levels of control here. Sometimes they just pipe it out to the outside and dump it outside. Sometimes they'll have a separate building or separate room for the storage of the wood dust. Sometimes they'll just keep it in metal bins. Sometimes they'll keep it in like the bags like you see on this vacuum. So we just want to identify where they're storing that dust and how often they're removing that dust. Well, that brings me to the end of the material we had for the presentation here. Are there any questions that I can address for you before I end this session? All right, well, I do appreciate you guys spending the time with me again this morning. So if you have questions, by all means, let us know, contact us. We want to help you out. We want to make sure that you're prepared to do these inspections and feel empowered to do them properly. It's much easier for us to address your questions while you're doing it than it is for it to come in incorrectly. We have to either correct it or send it back to you and explain what needs to be corrected. So we'd much rather work with you on the front end to have it done correctly in the first place. So you can contact anybody here in our office. We have 2 trainers that are available for you. So you can contact us at any time and ask us your questions. We want to help you out. But since there's no questions, I'm going to go ahead and end the meeting, and I hope you guys have a great day.